This is section 2.3, and we are going to see how we can find the mean from a frequency distribution. So what we have here in this example is a large data set, and this data set actually has 50 different speeds of drivers in Oak Ridge. So these drivers were clocked for their speed, and what we found was that there was 25 drivers going between 42 and 45 miles per hour. There were 14 going between 46 and 49 miles per hour, and so on. So we don't have all 50 individual pieces of data, but we do have this frequency distribution. So we have an idea of what this data looks like. So what we want to do is, looking at this, can we figure out what the average speed was of all 50? So what we don't know is there's 25 people going this speed between 42 and 45 miles per hour. However, we don't know if all 25 were going 42, or maybe all 25 were going 45, or maybe they were just all over the place in here, some 42, some 43, and so on. So the best we can do in this situation to find the average speed that these 50 drivers were going would be to consider the midpoint of each class, and then we would just consider that all 25 drivers in this class were going the actual class midpoint. So if you remember, a midpoint is found by taking the lower class limit plus the upper class limit and dividing that by 2. And that gives us the middle value. So the average, or the middle speed in this class, was 43.5. So we would just do the same for each class to get the class midpoint. So the middle speed here in this class would be 47.5 miles per hour. This one would be 51.5. This is 55.5 and 59.5. So what we're going to do is we're going to consider the formula that we have for the mean for a frequency distribution. And to do this, we need to add up all of our x values, which is our class midpoints, times the frequency count. So let's get those values right here. So our class midpoint is 43.5 times the 25 drivers we're going to assume we're going 43.5 miles per hour. So 43.5 times 25 times 25 is going to give us 1,087.5. 47.5 times 14 is 665. 51.5 times 7 is 360.5. 55.5 times 3 is 166.5. And finally, 59.5 times 1 is 59.5. Now, the summation symbol here just means let's add up, let's sum up all of our x times f. So x times f is this value. We're going to add all these up, and if we total that, we get 2,339. So we have everything we need to use the formula. So the formula for the average speed of this data set is going to be our x bar, this is the sample mean, we have a sample of 50 drivers, is equal to the sum of all of our x times f's divided by the sum of all of our frequencies. So this specifically then, this would be, if we sum up all of our x times f's, we get 2,339. And if we sum up all of our frequency counts, we have 50. So doing the math, we get 46.78. Now that took a lot of work, and imagine if this was a larger data set, it would take even longer. So we do have StatCrunch here, and this is how we can do this in StatCrunch. So I wanted to show you over here. I already entered all the speeds here. These are our classes, our lower and upper limits, and this is the frequency count. So all we need to do is just go to Stat, and then summary stats. And the only thing that's a little bit different is that we have what is called grouped bin data. We do this when we have the two columns of data in a frequency distribution. And then we simply tell it to look in var1, and then our counts, our frequency counts, are going to be in var2. And we can highlight any statistic over here that we would like and hit compute. So there is the mean that we were looking for, the 46.78 that we got over here. We also have our standard deviation. We're going to use this in this class. Here's our median, min and max, Q1 and Q3.